In 2006, 80 deer were introduced into a wildlife refuge. By 2012, the population had grown to 180 deer. The population was growing exponentially. Write an algebraic function, n of t, representing the population n of deer over time, t. Write an algebraic function, n of t. That just means write an equation. And our equation is the growing exponentially equation. That's going to be this one right here. Okay, in this function that we're making, population is n and time is t. Well, we know a couple of things. We know that in 2006 there were 80 deer, and in 2012 there were 180 deer. Well, we don't want a year representing t, like the number of a year. We want how many years. So why don't we define t as the number of years since this began, which was 2006. If we do that, we can come up with a couple of ordered pairs. If t is 0, then it's 0 years since 06. That would be 06, right? So when t is 0, there were 80 deer, right? This is your t, and this is your population. Well, we also know that in 2012, 6 years later, there were 180 deer. So let's see how all of this fits into our formula. We're using this format. N of t is equal to a b to the t. Instead of x's, we have t's. Well, a is the initial or starting value. Well, didn't it start with 80 deer? So we have n of t is equal to 80 b to the t. In this is our population. This is our time. Don't we have those two things right here? This is our time. This is our population. So let's substitute those in. 180 is equal to 80 b to the t, which is 6. Well, we need to figure out what b is. So let's divide by 80. So we get 180 divided by 80. This happens to be a nice short number. If this worked out to be some crazy ugly long decimal number, you don't want to round. So for this entire section, actually for this whole chapter, never round anything until the very end of the problem. So what you want to do is just store it. Store it in your calculator. Alright, so what we have now is 2.25 is equal to b to the 6th power. To get rid of that 6th power, we have to take the 6th root, which is the same thing as raising it to the 1/6 power. Whenever you have a power to a power, you multiply the powers, that reduces to 1, and you end up with b is equal to the 6th root of 2.25. So I already stored it in x. So I'm going to do x to the 1/6 power. And I get approximately 1.447. So this time I can round because I've actually reached what I'm looking for. Forgot my 1 right there. 1.1447. So now that we know b, we can go back up here to this part. We're going to have n of t is equal to 80 times b, which is the 1.1447, all to the t power. We have our function.